Hello and welcome back to National 5 Trigonometric Identities, question 7 up to 10 from the work that was set. So question 7, we need to show that cos x plus sin x in a bracket all squared equals 1 plus 2 sin x cos x, or cosine x. So bracket squared, we always need to do bracket multiplied by bracket. So we need to use FOIL or just make or the rainbow loops or whatever we want to call it. But essentially what we're doing, we're making sure multiply both of the terms in the first bracket by both of the terms in the second bracket. So the first term in each bracket, cosine x multiplied by cosine x, we write as cosine squared x. Cosine x multiplied by sine x, we could write as cos x sine x. Sine x multiplied by cosine x, we can write as sin x cos x. And sine x multiplied by sine x, we write as sine squared x. Right. Now at this point, remember, if we see a sine x divided by cosine x, we replace it with tan x. If we see sine squared x plus cosine squared x, we replace it with 1. So there's my sine squared x at the end, cosine squared x at the start. So sine squared x plus cosine squared x, I'm just writing that at the start there. And then cos x multiplied by sine x is just the same as sine x multiplied by cosine x. So we've actually got the same term twice here. But again, I'm just writing them out to show exactly where this final answer is coming from. So sine squared plus cosine squared x will be 1. And then sine x cos x plus sine x cos x will be 2 lots of sine x cos x. And that is the answer we're asked to show. Okay, let's have a look at question 8, similar question. So here we have cos x plus sine x multiplied by cos x minus sine x and plus 2 sine squared x. So, this picture is a little bit fuzzy. Sorry about that, guys. But again, multiply out the brackets using FOIL. So we'll get cos x times cos x, which is cosine squared x. Cos x multiplied by minus sine x, so minus cos x sine x. Sine x multiplied by cos x, which is cos x sine x. And then plus sine x multiplied by minus sine x will be minus sine squared x. And then it does say at the end, plus 2 sine squared x. Right, so next we have minus cosine x sine x plus cosine x sine x. So we've basically got minus of something plus exactly the same thing. That is going to total up to 0. Just like minus 1 plus 1, 0, minus 10 plus 10, 0. Minus cos x sine x plus cos x sine x is also 0. What we've got at the end, we've got minus sine squared plus 2 sine squared. So that'll give me plus 1 sine squared x. So I've got cos squared x from the start here, plus sine squared x at the end. And as we know, cos squared x plus sine squared x equals 1, which is what we're asked to show. Let's have a look at number 9. Right, 9 and 10, ones where you have to take out a common factor. Okay, so remember, we're looking for either tan x, sine x over cos x, or sine squared x plus cosine squared x. So here I've got sine cubed, I've got sine x cosine squared x. I'm going to take out sine x as a common factor here. Remember, cubing means multiplying by itself 3 times. So I'm going to take out sine x as a common factor, because sine multiplied by sine squared would be sine cubed. Sine multiplied by cos squared would be sine x cosine squared x. Okay, what have I got in this bracket? Oh, look, it's sine squared plus cos squared again, which is just 1. So we've got sine x multiplied by 1, which is sine x. Question number 10. Again, we're looking for sine squared plus cos squared if we can get it, guys. So here, to get sine squared on its own, I need to take out a common factor of cos squared here. So cos squared multiplied by sine squared, we give cos squared sine squared. And here I have cos to the power 4 of x. So it would have to be cos squared times cos squared to get the cos to the power 4x. Again, once that common factor is out, in the bracket we have sine squared plus cos squared, which is just 1. So I've got cos squared x multiplied by 1, which is just cos squared x, or cosine squared x, as I should say. Okay, right, these are quite tricky. Have a look back over them if you need to. Try them again in a day or two's time and make sure you can do them.